and I will put the answer there.
Okay, so let's start today's meeting. So thanks everyone for joining us today. I'm today's host, Fog, and in today we will have two agendas today. So first, Da will give a little brief introduction to the observability add-on suite, and then he will introduce the pure Q style add-on. So Da, can you share your screen?
Let me share it. Okay, can you see my screen? I think it's in the browser page.
Yeah.
Yeah. Okay.
Yep.
So in is the introduction finished? Then I will start with the first section of this today's community meeting. Okay, so the first part I would like to introduce is one of the important feature for KubeVela version 1.5. It's about the observability add-ons. So we know that installing KubeVela into your Kubernetes system can help you to do the application delivery and manage your application. But before version 1.5, there is not much tools for you to check the system healthy state. For example, whether your controller has a high load, or your Kubernetes API server is not working correctly. So to diagnose these problems or have a more detailed information for your inside system, we leverage the power of community observability applications such as the Graphina and the Prometheus. So basically, the observability add-ons are generally a set of applications or KubeVela add-ons, currently including Prometheus server and some exporter like node exporter and state metrics, and also the Graphina dashboard, which can provide you a visualization for all your metrics. So in the following versions, like version 1.6 or 1.7 in KubeVela, we might add more related add-ons, such as the logi part and some open telemetry part to add more capabilities for the logging and the tracing part of the observability. So generally, I will introduce how you can use this observability add-on in your KubeVela system, and it's quite easy. So if you go to the catalog where we have lots of KubeVela add-ons, you can now see that in the add-on folder. Okay, then there are like Graphina add-ons already, and also node exporter and kube state metrics, and also the also the Prometheus server. Yeah. So unfortunately, I haven't finished the documentation, but I have raised a pull request at the KubeVela.io, this repository. So if you want to have a try for the observability suite, you can refer to this page and see the documentation here. And later we will release this README documentation into our official documentation site, so that you can see the documentation very easily. And let's start. So since it might need some time to install the add-ons, especially for the multi-cluster scenario, so I will just introduce how to install it, but I will not show the process of installing it. So for example, before everything you start, you need to install some metrics collector, including like kube state metrics. This will help you to collect the metrics from the Kubernetes system. And also you can have the node exporter metrics, which can help you to diagnose the information inside your underlying machine. For example, your Linux system or other network-related things. So these collectors are not required for you to use the observability add-on, but we recommend you to install it in your system so that you can have more metrics to inspect your system. And then we will have the most important part is the Prometheus server. So instead of compared to the community version of Prometheus installation, currently we do not we provide the most simplest installation for the Prometheus server without the alerting manager or other related things, which might give you a lot of burden to your system. But we will add those add-ons in the future as well. And one of the things you might need to notice that is that the Prometheus server here, we naturally support multi-cluster part. So if you go to the multi-cluster installation section, you can see that with some simple parameters added to the command of enabling the Prometheus server, you will be able to have a Prometheus server that can have multi-cluster metrics collected. And then it will aggregate those metrics into one metrics provider so that the Graphina part will have a global view for all the metrics inside multiple clusters in your KubeVela system. And also, I would like to mention that the add-on enable part for those nodes collectors, if you do not specify the clusters to specify which cluster you want to install, by default, they will be installed to every clusters. And okay, and finally, you will have the Graphina add-on to install. And with this add-on installed, you will have some internal dashboards installed by default. And also you can add more dashboards for your applications or your scenarios. So it's very easy for you to have everything start with just several simple commands. Okay, so I will show you, so this cluster, I would like to give you the introduction. It has already installed all the required add-ons. So you can see that we have those add-on applications installed inside the Vela system. And I would like to notice to mention that before except for the four mentioned add-ons, there are also two dependencies which will install automatically if you enable the Graphina add-on. So Prism, this is introduced in KubeVela version 1.4 as an optional add-on. So it will help you to manage the Graphina APIs in the observability part in KubeVela as well. So I will recommend you to install this. And also we have some internal definitions for use Graphina, and I will show you a bit later. Okay, so after installing these things, what can we do? So first, I would like to show you that if you install for example, if you install the kubestate metrics, you will see that this add-on is by default installed to all the clusters. And also, if you go to see the Prometheus add-on, you will find that to aggregate multiple cluster metrics, there will be additional installation for the local cluster, for the hub cluster. And for the other managed clusters, the installation will be much simpler. But these things are not, you do not need to care about them because these are automatically done inside the add-on itself. So all you need is just type this simple command and let it work. Okay, just this command, it will work. And also, we have seen that these have been installed into the cluster, and we will see that there will be some service inside the installed namespace. For example, the Graphina part. So currently, by default, we do not expose the Graphina dashboard to the outside network. So you will need to use some command like port forward to do some projection of the port mapping. And also, if you would like to expose it, you can add some load balancer or have some gateway to provide access from the outside. Okay, so let's do the port forward. And let's go to the local host. And this is the Graphina we have port forward from the installed cluster. And these dashboards are internally installed, so you do not have to install it manually. And let's say the first one, the Kubernetes API server. So this is the dashboard for the for all the managed clusters and the hub cluster inside the KubeVela system. And you can check out the clusters by just clicking the checkbox and switch which one you would like to see. And here it will show that your Kubernetes API server, so how much request it has, and also the latency for the requests. So if your Kubernetes API server is not responding very quickly, you can go here and see which request is making it slow. And also there are some details for you to debug and diagnose underlying problems. So this dashboard is pretty useful if you have a lot of KubeVela applications inside your Kubernetes system, because if you have a lot of applications, such as you have thousands of applications, there will be lots of API server requests. So the Kubernetes API server will have a lot of requests, and you need to figure out which one might make the overall system very weak, and you might to do some optimizations for this kind of requests. So after that, you can go to the KubeVela system itself. So this dashboard will focus on the KubeVela system itself, including the resource usage of the KubeVela controller, such as the memory and the CPU. And with this part, you can see that if your controller is working at a healthy state. For example, if your memory usage is already over 80%, then it might trigger like OAM queue sometimes later, because your system currently is hard to manage so many applications. So if you find that your memory usage or CPU usage is always very high, it might be better to increase the requested resource for your Kubernetes for your KubeVela controller. And also, if you have lots of requests and you would like to debug which part of the KubeVela application is working slow, you can also go to the detail part and see the average time consumption and also the API requests and see which resource it is managing now. And also, there is a simple view for all the component definitions and trait definitions, and also the workflow step part. You can see these. You can see those definitions from the Graphina dashboard as well, and also there are dashboard for all the applications as well. Okay, so this is the overview part. And if you want to see details for the application, so currently we provide the overview for the application itself. For example, we can see that for the Graphina add-on application, it shows the deployed resources and also the component and policies it is using. And also we also provide a link for those deployment resource currently. Maybe we can add more resource later. For example, currently we are running the Graphina deployments here, and you can click the detail and it will switch to another dashboard. This dashboard is the Kubernetes deployment part. It focuses on the deployment itself, including the pod itself, and also the replicas, and also its usage, including the network part, and also the CPU and memory usage. So with this dashboard, you can focus on your business applications or your single applications to see what things happen inside that application itself, instead from general overview. Yeah, so this is basically the overall of the observability add-on suites we would like to introduce in KubeVela version 1.5. And these things, I think you can try it in version 1.5, beta 0.4. Yeah. So if you want to have a try, currently it is available, but the documentation is not ready now, but we will release it in, I think in 1 week, we will release it. And we will have some more documentations to describe it. Yeah. So for the first part, is there any questions?
Hey, this is very good, and it's I think you're pretty much giving the visibility to a lot of things. One question I have for you here is like, how, I mean, like we are using some internal observability tools, like, you know, when we say internal, we're using other observability tools like Datadog. So how do you see this, like, you know, see this integration with other observability tools like Datadog or any other tool?
Yeah, so for other types of observability tools, like as you said, the Datadog part, we currently do not provide the direct integration for these tools. But another things we are considering is that, for example, the Graphina part and the Prometheus part we are showing to you is that you build it from the add-on part. But if you already have Prometheus server installed in your Kubernetes cluster, you do not necessarily to install it again through the Vela add-on. We provide some capabilities from the Vela Prism. So this the Prism will allow you to manage those data source and the dashboard for Graphina through the native Kubernetes API. For example, in this cluster, currently you can run kubectl get Graphina, and it will store the credential for accessing the Graphina part. As you see, that's the access point and the access password and username. So if you already have some Graphina installed inside your cluster, or you buy the Graphina service from some cloud providers, you do not need to install it again in your cluster, and you only need to just to set up this credential part, the Graphina resource inside your cluster. And after that, for example, you can manage your data source, for example, like the Prometheus part. You can manage it through the native API as well. Okay, so if you have another Prometheus installed in your cluster, and also you might buy some Prometheus service from cloud providers, and you also, what you need to integrate with KubeVela is that you just need to place that data source inside the cluster to use the native Kubernetes API. It is pretty straightforward. So this is one of the integration for KubeVela add-on, and the outside pre-installed observability tools. But as for the Datadog part, which we are not currently integrating with, I think we need more community contribution to this part of scenario. I think we can support it later, but for now we do not have any progress on it by far. Yeah.
Inda, let me add some details. I think Datadog can integrate with Prometheus server. So as you know, we have already installed Prometheus and Graphina as separately. So maybe you don't need the Graphina part, and you can use the Prometheus data source to integrate with your Datadog. I think that there need some work, but it won't be long to integrate it.
Yeah, got it. I think that helps. We can explore on that area, and we can sync up later as required.
Yes. We will also try to integrate Datadog in the near future.
Just an opposite observation is, the Cube Prometheus module is already kind of there and created, which combines Grafana and Prometheus, but also some rules for monitoring. There's advantages in installing them separately so people can choose. There's also advantages in using that pre-cooked Cube Prometheus. I was wondering if you had any plans to use that.
Sorry, I didn't follow up completely. Are you talking about like the recording rules or alerting rules?
There's Prometheus Operator,
Oh,
user
I
in
know.
GitHub has Cube Prometheus, which is pre-cooked with all of the rules and everything together. So it can be advantageous to use this as well.
Yeah, I know that before I work on this observability suite, I also try to have some the Prometheus operator and inside the add-on part. I think it's okay. It's completely okay to use the Prometheus operator to create your Prometheus instance and also the related components. But I think one of the advantage to use Prometheus installation inside the KubeVela add-on part is that it's we did some multi-cluster connection so that with the use of Thanos, we aggregate the multi-cluster metrics, and I think the native Kubernetes native Prometheus operator might be hard to do that. But I think it's a pretty powerful tool if you want to manage your Prometheus instance inside just one cluster. And I think we can try to add a Prometheus operator add-on in the catalog parts in the future as well. But I think you do not need to necessarily use all the add-ons inside KubeVela. So if you already have your Prometheus operator and it is working pretty very well, I think these add-ons you do not need to install it one by one. You just install which one you need, and you what you might need to do is to copy the dashboard part or use the declarative APIs to register your data source and your dashboard into your existing Graphina instance or manage your Prometheus instance.
Yeah, so my thought was more that not that you would use Prometheus operator separately, but that it would be an add-on that you would use under Vela, because as you say, you would have the customized dashboards, but you'd also have the Prometheus rules, etc., that Prometheus operator offers. So I wasn't thinking of having it separate. I was thinking of it as having it as a Vela add-on.
Yeah, I think it's a good idea, and we can make it a bit later. The Prometheus operator is pretty good. I think it will help the KubeVela users to leverage the power. Yeah.
Yes,
but maybe you make a good point about the multi-cluster. Maybe that's where it would be a problem. Anyway, I was just offering it for a thought. Yeah.
Yes, we can investigating more issues around it.
Sure.
Let me add something. It's really a good question that I have discussed deeply with Inda before we actually go in this work. And our plan is just like a line. One side of the line connects to the server, which is Prometheus or other observability server, and one side of the line connect to the Graphina or other UI console. And you can use the observability add-on or use your already installed Prometheus server. And on the other side, you can use some cloud services such as Datadog, or just install the Graphina add-on provided by the community. So the solution will provide enough flexibility. So it's just like a line that can connect both sides. So the first solution that we don't want to add the burden that one user just want to enjoy or experience the observability capability, but they need to launch lots of pods. It will cost lots of resources. But I think the Prometheus operator is necessary, and it's not that hard to add it as our add-on.
Thanks for your thoughts. That's interesting.
Okay, is there any questions for this part? Okay, so if you have more questions about the observability add-on, you can add some issues to our KubeVela repo. And when I was showing that observability add-on, I would also like to introduce another mechanism for building add-ons in KubeVela. So previously, when we built KubeVela add-ons, the add-ons are actually they are KubeVela applications. Just like we have some templates to build that KubeVela application. So this is basically the original KubeVela add-on, what it is doing. So in version 1.5, we make it a further step towards the Knative part to build the KubeVela application. So let's see how, for example, I just show you that we can use the kubestate matrix to build the to provide the matrix, and let's see how we build this kubestate matrix with the new mechanism. So let's go to the catalog part and go to the add-ons and kubestate matrix. So now you can see that the kubestate matrix add-on currently will have the several Q files, including the kubestate matrix part, which declares the main component inside the kubestate matrix. So this is basically the deployment, actually the KubeVela web service, and also includes some traits to declare the privileges it wants to use, and also the service it will be exposed, and also the resource it would like to use. So you can see that the parameter actually is the templating parameter, which will be used to render the final KubeVela application. And so with these Q parts, you can assemble your KubeVela you can assemble your KubeVela add-on through Q files. For example, you can also see that the parameter.q, this file declares declares what inputs of the add-on the user can use when it's use the kubestate matrix add-on. And also there are the whole templating queue. So this is the assemble part for the KubeVela application. And the output part will output a native KubeVela application, and the application is written in Q. And you can see that the component part will use a kubestate matrix. This variable is just declared in the resource kubestate matrix. Yeah. So what can you do with these structured Q files? We can use the native Q commands to do the rendering. Like here we use it to with this Q command. With this Q command, you can get the complete add-on application, which you would like to render and apply in the final stage of the add-on. And with these things, you can use the you can leverage the powerful QLang to build your add-ons. For example, you can have some if-else sentence, and also you can have some for loop to make your application running part more easy and more powerful, I think. And also, you do not have any black box logic behind the add-on rendering part, so that when you have those Q files, you will get the final application YAML file as well. So the Vela add-on enable part, you can treat it as just get all the Q files inside the add-on directory and then assemble them, and then get the outputs field inside the Q part, and then apply the application, render application. So this is one of the new add-on render mechanism we added in version 1.5. I think this feature will help you, especially for those who are very interested in using QLang to build your Kubernetes resources to integrate it with the KubeVela application. Okay, so that's the second section for today's community meeting. Is there any questions for it? Okay, I think there seems no one have the questions by far.
Okay, so I have sent a link of our meeting notes in the chat, and please, it would be nice that if you can add your name and company in the attendees of the meeting notes. Thanks, and thanks for the supporting to the community. So before we wrap up, is there any questions or anything else to discuss?
I have one topic.
Yes, please.
Yeah, not necessarily a question. This problem is already addressed, but you know, this is from Guidewire, and you guys probably know that we use KubeVela heavily. One of the recent things that we have noticed is the add-ons did not have the versions, so that created some conflicts because in the previous version that we have released a couple of months back, ops noticed that it started pulling latest because it did not have the version support. So that created some mess in production, and we have to get a hard fix and apply it. Things are fine now, but I just wanted to share that feedback if you have not heard it directly from our team yet.
So I can give more details what happened. So we are using Terraform controller. We didn't explicitly enable Flux CD. Since it has a dependency of Flux CD, we were using the Vela CLI 1.4.1. We released this version a couple of months ago, like a month and a half ago. What happened, since we don't have explicit Flux CD version enabled, since we did not install, it is installing Flux CD. And the Flux CD has the dependency somebody released a couple of days ago. The metadata ML expecting the Vela CLI more than 1.5.0 beta 4. Seems like there is no central coordination. One plugin, I don't think the plugin has to be upgraded all the way to the 1.5.4 beta version. So we have to explicitly install Flux CD and choose the specific version of Flux CD, which works with the Terraform controller version, whatever we have.
Okay, so as for the Flux CD, the add-on, especially for the Flux CD controller, actually we are also addressing these similar issues. Not very similar, but I think might related issues in version 1.5 as well. Because it is true that using Flux CD inside the KubeVela system can have some experience trouble, especially when you need to upgrade Flux CD or you delete the Flux CD add-on, and the auto recycle of the CRDs inside the Flux CD, for example, the Helm release part and Helm repository, this CRD. So if you misdelete those things, it will cause a lot of troubles, and you need to fix it manually. I think it is a big trouble, and we are seeing some users, especially for the Helm users, facing the similar problems. So our team is continuously optimizing the use experience for the Flux CD add-on. For example, we are going to do some split for the Flux CD add-on, including like to break apart several controllers into different things, so that you only need to install the minimal part you want to use. And also the CRD handling part will be more careful. For example, we will make it ignore the recycle of the CRD part, so that it could be more safely to use it. And I'm not sure if this enhancement can help you to improve your use experience, but if you have something want to optimize during using the Flux CD part, especially if you already have some best practice inside your scenario, I think it will be glad to see that other community members can know your techniques to do this job. And also, if you encounter any problems, you can also post the issues on KubeVela and make some discussions on it. I think it's good to do so.
Okay, thank you. I'll post the details after this meeting in KubeVela.
Okay, thank you.
Mhm.
Okay, so any other questions or discussion?
So I
Hey,
was
one question on the issue that we just discussed, right? So to not repeat or at least to overcome these issues in the future, like any steps that we should be aware of, or anything that you can bring it up so that these can be avoided, or like this can be reduced in the future?
You mean the CRD part?
Yeah.
Yeah. So we are actually we already have policy part named garbage collect, where you can specify which resource you would like to ignore during recycling the application. So you can name some resource to skip the GC part, or you only want to GC it when the application is deleted, instead of the upgrade part. So this is configurable. I think this feature is introduced in 1.3, but recently we are fixing a bug for it. Is that you cannot first to declare one resource to be recyclable, but then you declare a policy to say that, oh, this resource I do not want to recycle it anymore. So we cannot make this change. So it is hard to make our Flux CD add-on to upgrade to the CRD ignore part.
And it's available in one of the latest versions, you said, right? This one?
Yeah, we just fixed this tonight. So I think it will be released in next official version. I think in 1.5 official release, you will have this feature. Yeah.
Okay, thanks.
So one other question. So I heard, like, you guys heard some changes to deleting the, whenever we issue a namespace deletion, deleting the components under the namespace properly. That issues got fixed properly? Like what I mean to say, like, let's say we have a couple of KubeVela components under the namespace. If we issue a direct namespace deletion, will that individual components actually is the proper cleanup? Let's say we have a DynamoDB RDS components. So without deleting those components, if we issue directly namespace deletion, will that take care of deleting of those components?
Yeah. With the garbage collect policy, you can declare the namespace or some special component to ignore the recycle parts.
Mhm. Can you elaborate a bit more how it works? Like when you say ignore.
Okay, so let me find some documentation. I think I can share the screen. Yeah. Yeah. Can you see me?
Yeah. we can see.
In the official sites, there is a documentation. Let me find it. The search engine for our
Maybe you
is-
need to change the version to the latest, not the, yeah. Oh, next.
You can also search at a homepage. Then the
Yeah.
search.
Okay, I think this is the documentation you want. And let me see. So yeah, so here is an example. Like in this application, you declare components to use, although it is pretty simple here. You might make it some database components or some namespace part. And you use this policy named garbage collect, and you have some rules to select which resource you would like to apply the strategy. For example, here we use the component type to select resource. So all the resource under the web service typed component will use the strategy of never. So never means that this resource will never be garbage collect. So this is the meaning of this policy. And also you can use component names, or other you might need to use the resource types. For example, you want to disable the deletion of all the namespace resource, you can use resource types, and here you use namespace, and it will select all the namespace in this application. And also you can change this strategy from never to on app delete or on update. So we have three strategies here. So I think you might need to use this strategy so that I need to mention that although the strategy never means that it will never be garbage collected, but if there is any upgrade to this component, it will take effect. Yeah.
Yeah, let me tell our use case, see how we can resolve this issue. In one of our lower environments, we create some tenant-specific configurations. It's kind of a testing, like the tenants will be created, and after a week, so what we using, like we're not going individual components and deleting it at a bulk. We are issuing a namespace deletion earlier. So now what's happening when we're issuing a namespace deletion, since we already have some RDS components, DynamoDB components, those components not bailing out to delete the namespace, and the namespace is still in terminating status. So with this new approach, when we say garbage collected, never, that means it will never be deleted, correct? That's the use case. But is there any option you told that other two options, right? On update and on application delete. Is there a way we can say on namespace deletion so that that a feasible option? Because in production, we don't go and delete a namespace directly, right? We ensure that all the components are properly recycled or destroyed before we deleting any tenant from the production. From the lower environments, the people are not spending a time to go and deleting individual components. They used to delete the namespace earlier, but now it is blocking the namespace deletion.
So could you make it's a bit more clear that you mean you want to stop the deletion of the namespace or the delay the deletion?
I want to delete the applications if the namespace is deleting.
Okay, so you mean like when the application is deleted, you want to recycle the namespace?
Yes.
Okay, so then you can use this strategy. So this means on app delete means the upgrade of this application, or if you misdelete some namespace part inside the component, it will not affect the namespace. but once the application is deleted, the namespace will be recycled.
But we have to do individual component deletion, right? Let's say we have hundreds of components in a namespace. If I want to recycle the namespace, I have to go and issue individual components, correct? First, and then issue the namespace deletion.
So you want to delete those databases, those Terraform components normally, and let the namespace to be handled separately.
No, so let's say, let me explain it a bit more, right? Somebody created a namespace and couple of KubeVela components, okay? So they're not cleaning up individual components, but they're going and deleting right away the namespace. So now the problem is, since we did not clean up the KubeVela components, the namespace is not terminating because it's still holding off some finalizers. So is there a way which we can trigger deletion of all the application components when we deleting the namespace?
So I think one of the possible solution is that you need to place the application which holds those components inside the namespace, those component leaves. Is it possible in your scenario?
I don't know, but I have to go back and look at it. See what you're saying under the namespace resource component, we have to add all these components. That's what you're recommending, is it?
Okay, because if you place that application inside the namespace that is going to be recycled, the Kubernetes mechanism will automatically trigger all the resource recycle inside that namespace. And then it will trigger the application recycle as well. The recycle of the application will then recycle all the components inside it.
Okay. So is that the Kubernetes feature which you're referring, defining the resource component under the namespace?
I think you can specify the namespace of the app. I'm not I'm not making it clear. Could you explain it a bit more?
So, how do we define under the namespace all these component names?
So if you do not specify the components namespace, I think if you place that application inside some namespace, by default, all the components are placed under the application namespace as well.
Okay. Yeah, let me read it more about how we can do that.
Okay, we can make another issue and discuss more on it. Or Slack is also available. Yeah.
Okay, so we'll try some approaches and see how that goes, and then I will inform in the KubeVela dev channel.
Okay. Okay.
Okay, I think we have discussed enough long time. So thanks for joining us today. And the recorder of the meeting will be uploaded to the OAM channel in YouTube. And the meeting's over. Thanks for joining us today and see you next time. Bye.
See you next time.
You.
Thank you.
Bye.